Hey guys, this is Mr. Grice for Algebra 2, Chapter 3.6 Notes, Day 3. Today we're talking about applications of distance and money. Our learning target today is to be able to solve application problems involving distance and denominations of money. So let's begin. The distance formula, in case you didn't already know it, that the distance equals the rate times time. Okay, and if you forget that the R equals your rate and T equals time. Let's go ahead and look at problem number 1. It says, if Martine was driving 0.6 miles per minute down Lake Street, how far did he travel in 7 minutes? Assume that there was no traffic and he encountered all green lights. Okay, so with formulas like this, I like to make sure that I write down all of the variables and then fill out the information that we know. Okay, the 0.6 miles per minute right here, this is kind of telling me that this is the rate. So 0.6. Right here, minutes, right there, that should be telling you that that's the time. Okay, so when we set this up, our distance equals our rate, which is 0.6, times our time. Okay, so off to the side, 0.6 times 7, 7 times 6, 42, and I have one number behind the decimal. So we get the distance equals 4.2, and we're talking about miles. Okay. Let's look at our next one. Okay, example number 2. If Josephina drives on a highway at a rate, there we go, our rate, 65 miles per hour, how long would it take her to reach a distance of 195 miles? Okay, so they're telling us something different this time, okay? They told us the rate again, it's 65 miles per hour, but they told us our distance. So the thing we're trying to figure out is we want to figure out the time. Okay, so our distance equals rate times time, 195 equals 65t. And to figure that out, we would want to divide by 65. 195 divided by 65, that is? Ooh, can't figure that one out in your multiplication charts, can you? So off to the side, I would pick a number and guess. Okay, let's guess 2. Okay, maybe it's 2. 2 times 5 is 10. 2 times 6 is 12, plus 1 is 13. And guess what? It's not 2. Let's try the next number because that's kind of close. Let's try 3. 3 times 5 is 15. 3 times 6 is 18, plus 1 is 19. So 3 equals t. And remember, they don't want that, they want hours. So the time equals 3 hours. Write it out, label it. And make sure to put a circle around it so we know that's your final answer. All right. Problem number 3, some of your favorite problems. These are called distance apart applications. So we know that Julie, that's our first one, is riding her bike on the path at 9 miles per hour. She passes another biker going the opposite direction at 11 miles per hour. We want to know how long would it take until the distance between them is 70 miles? So there's a lot of stuff that we need to do. Whenever we see problems like this, the first thing Ms. Carranza and I like to do is draw a little picture to help us understand it. Okay? So we've got two people riding a bike. Okay, here's my little bike. There's the handlebars. And there's the seat. Okay? And Julie's riding it, so we've got a girl riding the bike. And she's got a little ponytail. Okay? So this is Julie. Julie is going at a speed of what? Well, her speed is 9t. Okay? I don't know the time. Okay, but I know she's going at 9t, the 9 miles per hour. Okay? Now our other person, he's riding a bike too. Okay, so there's his handlebars. He's going in the opposite direction. I'm going to make him a boy. Okay, there he's sitting down. And he's going in the opposite direction. And his distance equals 11t. Now, the thing I want to know is I want to know when this whole portion right here, when it's in between them, is 70 miles. Okay? So hopefully seeing those two things together might kind of help figure out what to do. Okay? So combine those two equations combined, the 9t plus 11t, that combined is going to give you 70. That's their distance. Okay? So when you combine your like terms, we get 20t equals 70. To solve for t, we have to divide by 20. And we get t equals, well, 7 over 2. We got to show our work for that. Okay? So over here, I'm going to do 7 divided by 2. 2 goes into 7 3 times, and we get 6. 7 minus 6 is 1. I want to know the exact answer, so I'm going to add a 0, which means I have to add a decimal point. And 2 goes into 10 5 times. Yay! So I get that our time equals 3.5 or 3.5 hours. Okay? All right, let's look at 4. Stefan is traveling south on a road at 55 miles per hour when Patrick passes by in the opposite direction at 65 miles per hour. How long until the distance between them is 480 miles? Okay, so we've got Stefan at 55, we got Patrick at 65, and we want to know when the distance is 480. Okay, so the only thing now is we're talking about cars. So here's my cool space car. We got one person going 55 miles per hour. And the other guy, he's going a little faster, so he's going to have a little sports car. Woo! Don't you want one of those? And he's going 65. Okay? So my first one, the distance equals 55t. And the distance for our other guy is 65t. And I want to know when in between them it's going to be 480 miles. Okay, so just like the last one, we take the speed of Stefan and the speed of Patrick, and I want to know together when it's 480. Okay? So when you add 55 and 65 together, you get 120t equals 480. To get the t by itself, we divide by 120. You can see that the zeros cancel out, and 48 divided by 12, that's on your multiplication chart. You get 4, and that's a total of 4 hours. And that is your final answer. And I forgot to highlight my other answer. Okay, so the time it would take would be 4 hours. I think drawing the picture is very helpful for that. Okay, money denominations. Please pay attention to this part because half of the class didn't really know it. So there are two ways that we can talk about money. We can talk about money in terms of dollars, and we can talk about money in terms of cents. Okay, a penny is worth 1 cent. Okay, but if we write that as a dollar, it's 0.01. Okay, nickels are worth 5 cents, or another way to write that would be 0.05. Okay, dimes are worth 10 cents or 0.10. Quarters, 25 cents or 0.25. And a half dollar, which we really don't see anymore, 50 cents or 0.50. Okay? All right, let's go ahead and flip it over. First, let's just start with some basic money applications. If you have 12 nickels, how much money do you have? Well, are you going to sit there and go, well, 12 times 0.05 and kind of get out your multiplication chart? No. You know that a nickel's worth 5 cents, okay? So what we would do is we would just do 12 times 5, okay? And that's 60 cents. Now, if you're going to write that in terms of dollars, you'd write 0.60, and then that would be your final answer, okay? We move the decimal at the very end, okay? And the reason that we just did that, we're like, well, cents, okay? Cents, we know 100 cents equals exactly $1. Okay, example number 6. If you have 9 quarters, how much do you have? 25 times 9. That would give you 225 cents. But as a dollar, that would just be $2.25. Okay, what about 7? Well, if you have 8 nickels, that's 40 cents. If you have 7 quarters, that's 175 cents. Add those two numbers up. 215 cents, which is the exact same thing as $2.15. Okay? So whichever way better works for you, if you want to do it with the decimals right away, we prefer to move the decimals at the very end. Okay? Alrighty. Now, applications of that. Example number 8 says Hannah counts the money in the cash register. There are twice as many dimes as nickels. The coins are worth a total of $5.25. How many dimes and nickels are in the cash register? Okay, so the first thing that I noticed that they're talking about dimes and nickels. Okay, so I'm going to write over here dimes and nickels. Okay, remember, this is the first step that we do. Okay, and now just like in the last section where we said that we can't solve it with two separate variables, we can only have one, but we have to pay attention to the relationship. Okay, and the relationship tells us that there are twice as many dimes as there are nickels. Okay, now let's take a look. $5.25, this is talking about the value. This right here, this is talking about the number of coins. So how can I change it where it's talking about the number of coins to the value of a coin? Well, we know how much a dime is worth, right? A dime, which is our 2x, is worth 10 cents. And we know how much our nickel is worth. Our nickel is worth 0.05. Okay? We know that the dime right here, that's where the 2x comes from, and the nickel is the x, okay? And all we did was put down how much they are worth. All right, so when we multiply those two things, we get 0.20x plus 0.05x equals 525. Okay? And we've talked about how you get rid of decimals. Okay? Multiply everything by 100, or however numbers are behind. And voila, you get 20x plus 5x equals 525. Where now you can combine your like terms. And then to solve, you divide by 25. And we get x equals 21. I did that one fast because 25 is on your multiplication chart. Okay? Now, the only question is how many nickels and how many dimes? Okay? Well, nickels right here, well, that was your x. Okay? So we know that we have the nickels equals 21. And the dimes, well, that would be 2 times 21, which is 42. Okay? And so that's your final answer saying how many nickels and how many dimes do they have? Well, there you go. Okay. All right, let's take a look at the next one. It says Melvin has a piggy bank that contains $1 bills and $5 bills. So those are the two things that we're talking about. I'm going to write those on the side. Right away, I know that my variable, I'm just going to use x. There are 6 more $5 bills than $1 bills. So he's got more $5 bills. How many more? Well, he's got 6 more. Okay. And at the very end, it's saying if there's a total of $120 in the piggy bank, how much of each type does he have? Okay. And this is where we have to be very careful that once again, this is talking about the value, but over here, we're talking about the quantity. So the X that stood for my $1 bills, the X plus 6 represented my $5 bills, okay? So we have to multiply those out where we get 1x plus, and on this side we have to distribute 5x plus 30. Oh, guys, and I'm sorry. I forgot one little thing. Of course, I waited till this part to remember this. And it's not supposed to be 6, it's supposed to be 12. Oops. So that's supposed to be 12. It's 12 times 5, guys, is 60. I apologize for that. I forgot about that change until I was looking at my notes. Okay, so now we know what to do. We combine our like terms, and now we solve for x, where we would subtract the 60 6x equals 60, divide by 6, and we get x equals 10. Okay, so the final part is how many $1 bills and how many $5 bills? Well, the $1 bills equal 10. That's what we just figured out. And then 10 plus 12, that equals 22. And that's your final answer. But Mr. Grice, I want to know if I got it right. Okay, well, let's check it. Okay, how many $10 bills did he have? He had 10, and that's 10 bucks. How many $5 bills did he have? He had 22. Well, what's 5 times 22? 110. Add that up. You get 120. And that's exactly what they had. Okay? Well, guys, that's it for Algebra 2, Chapter 3.6 Notes, Day 3. If you have any questions, please come see Ms. Carranza or myself. Otherwise, thanks for watching.